All right, so we're going to take a look at another sample problem. This one deals with throwing a ball up in the air. Starts off, a ball is thrown upward. Has a little diagram with a person. Person's shooting hoops or something, and they take a ball and they throw it up into the air. Now, in this case, they're throwing it straight up into the air, though they've spread it out a little bit with the dots so that you can kind of see it go up and come back down, but it should be that they're throwing it just straight up and it comes straight back down. Okay, ball is thrown up in the air. They say, what is its maximum height? Its initial vertical speed is 11.6 meters per second. Ooh, kinematic values. So I'm going to write out my table. Delta x, v final, v initial, acceleration, and time. They tell us that the initial vertical speed is 11.6 meters per second. That's positive because it's going to be upward for a vertical set of motion. Okay? Let's see, initial vertical speed is that, and the acceleration of gravity is 9.8 meters per second squared. So they're telling us that the magnitude of the acceleration due to gravity is 9.8 meters per second squared. We usually use 9.81 in class, but use whatever value they've given us. Now, one thing to bring up is all of these are technically vectors. I get lazy and I don't always draw that in. Oop, not time. Time is not a vector. Time is a scalar. And so now we need to ask ourselves, I already pointed out that our initial velocity is upward, so that's positive. What about our acceleration? Which way does gravity make things accelerate? Downward. And we're going to denote downward by having a negative, so that's an important piece of information. Well, they ask how high this thing goes, so we're looking for delta x, or in this case, it's probably actually a delta y, since y is usually our up and down coordinate. So they're asking us how high this thing goes. Delta y or delta x, our displacement up to the top. Our problem is, we only appear to have two pieces of information. Now this is a common question, and that's why we want to take a look at it, because if it's the first time that you've encountered it, it's hard when you're looking at this and going, I only have two pieces of information, I don't know how to solve for the thing that we're looking for. Well, I want you to think about this. When we toss something up into the air, it's moving pretty quickly initially. Gravity slows it down, slows it down, slows it down, slows it down. And when it gets to the very top, how fast is it going? Well, it's changing direction, and that requires it to slow down, slow down, slow down, come to a stop, and then speed up, speed up, speed up, speed up. When it gets to the very top, the velocity at that point is actually 0 meters per second. That's when it stopped moving up and about to start coming back down. So at the very top, our final speed for this motion is 0 meters per second. If we're looking at the total or the maximum height there, the highest point that it reaches. Now this is a common thing to keep an eye out for. We've given you all the information, but sometimes when a value is 0, you don't necessarily see the number being given. That's why it's so important to think about the problem that you're working with so that you can try and see anything that you might have missed. All right, with this, we know that we're after delta x, so we want the equation that does not have time. So that's v final squared equals v initial squared plus 2a delta x, or in our case, maybe delta y. All right, our v final is 0 meters per second, quantity squared, equals our initial, which is 11.6 meters per second, quantity squared. So I'm squaring the velocity, the whole thing, units and all, plus 2 times negative 9.8 meters per second squared times delta x. Now we don't know delta x, so we don't have a number to put in there, but that's actually what we're solving for. It's our one unknown. So I'm going to multiply these out. We've got 0 meters squared per second squared, 0 squared, and our units also get squared. We get 11.6 quantity squared, so that would be 134.56 meters squared per second squared. Plus, I'm going to multiply this out, and we get minus, I should say, 2 times 9.81, 19.62 meters per second squared times delta x. That's just 2 times negative 9.8. Oh, I did negative 9.81. I'm sorry. Force of habit. 2 times negative 9.8 gives me negative 19.6 meters per second squared, and then times delta x. So the two I combined, I multiplied these out, and then plus a negative just gives me a minus instead. Okay, now what I can do, since I'm trying to solve for delta x, I want to get it by itself. Let's add the 19.6 meters per second squared times delta x over to the other side. Now the delta x is multiplied to it, so we have to take both of them over when we add them over. That gives me the following, which is 19.6 meters per second squared times delta x is equal to 134.56 meters squared per second squared. Now to get delta x by itself, I need to undo the multiplied, so I'm going to divide. So I'm going to divide by 19.6 meters per second squared. And I do the same thing here, 19.6 meters per second squared. Now real quick, our seconds squared cancels out, and one of our meters cancels out, but not the other one, so we're left with units of meters, and we get 134.56 divided by 19.6. We get, if I've done this correctly, that delta x is equal to 6.86, 865, so we'll call that 87 meters to three significant figures. Survey says 6.87 meters. There's our solution.